So, hello everyone, my name is Tomislav and today I'll be presenting, 5G from software developer perspective. As we said in the introduction, usually when people are talking about 5G, they're talking about the various speeds you are going to get because this is going to be the fastest internet ever, at least up until now. The latencies are going to be so low you won't even know you are away from the server you are trying to connect to. The number of connected devices will be huge, and this will of course bring revolution into machine-to-machine communications, because one of the use cases for 5G that we usually mention is the amount of cars on the roads, and they're all connected, and they're all talking to each other, and they're all self-driving. It's wonderful. And finally, we have the Internet of Things, which we have seen in the past few years. It's really kicking off, and if we look into the number of connected devices, more devices that are connected today to the internet are not devices used by us, but just machines that do their own thing. But this is what 5G will be for most human users. You'll open your cell phone, and in the upper right corner, you're going to see you're connected to 5G, and your battery is somewhat low. And yeah, that's true. I mean, most of the users of this, they're not us. They're not IT people, they're not developers, they're just users. I mean, we are users as well because we use our phones every day. We don't care how it works, we just care that it works. So, if we go into the first part is, let's say, the marketing part of what 5G will be. The second part is the engineering things. Okay, so 5G is the 5th generation 3GPP standard for radio access networks, which will bring us wonderful things, as we said. It also supports 3 different types of deployment, which doesn't tell you much, I assume, because you have no idea. I'm assuming most of you don't know what non-standalone is, or NR dual connectivity, God forbid if you know that one. But this is something important to us as engineers. And finally, the last part is probably most interesting to the telco people, the frequency ranges and I guess the bidding, which comes later with that. But all of these things, this is 5G, but this isn't 5G we see every day when we are working with the software and developing it. This isn't the 5G we see every day when we work with the software to develop it. This is something we have to look at. This is something you get to understand after a while. But this is not something you have to understand from the first day. Because, I mean, at one point, 5G, EN, GNB, CUC, that's perfectly understandable for someone who's working with it for a while. But if you're just starting off, no, you have no idea what that is. And it's not expected that you know. This really is the bigger picture as to how the telecom network looks or how the base station deployment looks. And now we are going to talk about our perspective, from the perspective of Ericsson, Nikola, Tesla, and the people working there. Based on the slide, you can already see that our perspective is much more brighter than either the marketing or the standard perspective, or the picture is white. Yeah. Anyhow, these are all of our products we have in our offerings for base stations, from antennas, digital units, radio units, etc. So when we are talking about the parts of the base station, I'll get to the part you see around the town later, because this is the brain of the operations, the so-called digital unit. Everything we do, that more or less everything we do there, because that's the brains of the operation. You want to connect to the node, this will tell you if you can. You want to you're traveling in a fast train, because the Balkans region is known for fast trains, and you want to have your connectivity all the time. You don't want, while watching YouTube, to have some interruptions. Of course, this will let the other base station know that you are nearing the end of the range, and it will hand you over. For you as the end user, it's seamless. You have no idea that something happened in, I don't know, 5 to 10 milliseconds that transferred you from one base station to the other. It works by magic. Of course, if by some chance it happens that YouTube stutters, that's due to YouTube. That's never due to Ericsson. The other piece of equipment is the radio unit. The radio unit, well, colleagues from radio get a bit miffed when I say this, but it's a fancy amplifier. I mean, And the part that's not the amplifier is the heatsink, because the amplifier likes to, well, be warm. And so you see this part, it weighs around 40 kilos, so it's for strong people only. And finally, the part you actually see around town is the antenna. This is usually the part of the base station you see deployed, because it actually needs to have some sort of visibility for you to be able to connect to it. Antennas have come a long way from the, I don't know, pieces of metal we are using perhaps still for our TVs. They are now much more fancy. They're a combination of many, many antennas which actually pinpoint the signal from the base station to you. This is something called beamforming, and it's also all the rage in 5G, because this actually lets us to give you, as the end user, better connection while using less power on the RBS side, on the base station side. But this is, again, our bigger picture perspective. Working every day with software, again, in the dark, because that's how we developers like to work, we have this. We have hardware we are running on. The hardware we are running on, it's either an ARM processor, an Intel processor, various FPGAs and ASICs we need to program to actually do the stuff we need them to do. To work with that, well, we use programming languages again. Some of you may have used VHDL or Verilog, which are languages for designing hardware, because to design hardware you still need to use software. Although hardware people will deny that, but yeah. On top of that, we have an operating system running on our base stations. This operating system is Linux. Of course, we need to adapt it, because base stations are not exactly your normal hardware that you see every day. Okay, you see them every day, but it's not something you are working on every day. And to do this, we are using C. Why C? Because, well, base stations are much closer to embedded computing than to any other kind of computing. Our resources are limited somewhat. We don't have the fanciest processor, we don't have a huge amount of memory. But that's not because we are cheap, that's by design. We want to have perhaps a slower processor, perhaps less memory, because we want to consume less power. And we don't need the latest, I don't know which generation of Intel is current, 12th or 13th. But we don't need it. I mean, it's not necessary for what we are trying to do. But as a side effect, we are using C, because we are using limited resources, and we don't want to have some huge virtual machine like Java does, which will use 2 gigs of RAM just to say hello to you and then promptly crash. If you use the clips, I'm sorry for that, if you have heard to use that. I'm not guilty for it, but I'm still sorry. Then, on top of that, we are using middleware and supporting services, because our hardware goes through different generations. I mentioned ARM processors. We had them up until a few years ago. Most of our product line used ARM processors. Before that, we used PowerPCs, which not a lot of people are now old enough to even remember. Now we have moved on to Intel. But what we don't want to do, we don't want to reinvent the wheel once we change just the processor. If you are doing normal software development, changing the hardware, if your software architecture is sane, is more or less recompiling for a different target. You will perhaps have to optimize, you will have to do some stuff like that, but you shouldn't have to write everything from scratch. That's why we have this middleware supporting services. This offers more or less same experience for everything that connects, everything that needs to talk to the hardware, but isn't that low in the software architecture chain. For that, we are using Erlang, which, as some people may know, is Ericsson language, but officially it's not called for Ericsson language. Officially, it's called for some guy named Erlang who did early signal processing mathematics, allegedly. I still think it's Erlang language, but let's leave it at that. And of course, some parts that are in C, C++, and C, because of course they are. They won't be in Java, they won't be in Python. We are still limited by the resources we have. And then we have IP connectivity, because to be able to connect to the outside world, we are using IP. The base station is the first point of contact between your cell phone and the wider world. The wider world usually talks via IP protocols. And I guess most of you have at least had some experience with them, at least if you have seen written HTTP in the browser status line, well, that's the top of the IP connectivity food chain. We are usually working with the lower layers because we don't care really much about HTTP. We're just transporting it from point A to point B. On top of that, and of course, not to forget, again, C++ and C. I know this was unexpected. Then we have 5G connectivity, or 4G connectivity, or 3G or 2G, but since the topic of this talk is 5G, I'm going to limit myself to 5G. 5G connectivity, again, I know, shocker, C++ and C, because, again, limited resources. But to understand 5G, I mean, we can go back all the way to that picture in the beginning. But if you want to actually do it, you don't have to know the entire picture in the beginning from the get-go. You're going to get your one small part of the universe, the bigger this universe, and you're going to understand that well. Then you're going to build on top of it. If I'm going to go back to this slide because I'm going to tell you my perspective. I've been in Ericsson for 10 years and 11 years almost. And the question I usually get when people are talking about Ericsson is, oh, so you're working with the cell phones. Yes, but not in a way you think. Because last time Ericsson actually had a cell phone, it looked like this. If you still have a cell phone looking like this, you're either very old, a tech enthusiast, or been living in a cave. Pick any of that. My father has a similar cell phone. He's old. So, even to the point that I heard from some colleagues in Zagreb that people used to come to our company with their phones asking if we can fix them. Because that's what Ericsson is, phones. So if you retain anything from this, just please remember, we are not doing phones. We haven't been doing phones in at least 8 years, not even as a logo on the phones sold around the world, and more than 15 years, I think, as a company in general. What my colleagues think I do, yeah, as a normal developer, you turn coffee into code. So yeah, my colleagues think I drink coffee, and often they are right, sometimes they are not. But in the end, what I actually do is this. Of course, this is my graphical user interface, which is not a graphical user interface, because I'm old as well. I dislike graphical user interfaces. I have to use my mouse there, I don't like it. But this is wonderful, and also, if you want to look really professional while doing your work, black background, green letters. I mean, if TV has taught us anything, that's wonderful. But from my perspective, this screenshot actually contains something that the corporate didn't bless, because this is the snapshot of actual code. But if you get anything from the E1 bearer interface, you're wonderful, and we want to hire you. But other than that, my perspective was I started in this IP connectivity part in an older product, and initially I had no idea what I'm doing. Because that's normal in the beginning, you have no idea what you're doing. I knew some things, I knew how to program, or so I thought. Because at one point I came to the realization that the idiot who wrote the code was me 3 years ago, when I was looking at someone else's code. And building on top of that, I worked with middleware and supporting services closer to this, OS Linux adaptations, and for the past 4 years, 4G and 5G connectivity. What's wonderful about that, you have used my code. You have used it even if you didn't want to, because it's running on a base station, which is processing the traffic you are generating daily by just taking out your phones, opening Facebook, going to Instagram, reading news, calling someone, whatever. You're going through the code I have written and my colleagues have written. And that code is running at millions of base stations really around the world. The downside of that, not many people know that we have written that code. I mean, I know the code I've written. And not many people will remember, oh yes, Tomislav, he's great, he wrote the code for that and that. But if that and that stops working, everyone will remember Tomislav wrote that code because Tomislav should fix that code. But that's just the reality of work. And another wonderful thing is you don't get bored, because this is complex. I mean, we could go back all the... Could we? Yes, we could. We could go. Can we? Yeah, we can go all the way back to this picture here. Once you come to understanding this, you've made it in life. At least I think I've made it in life and I understand most of this. And it's wonderful because then the entire process of you taking out your phone and trying to access Facebook becomes less of a magic and more of, oh my God, that really works because of something I've done. I mean, the base stations deployed around the world, some of them have been connected because of the code I have written or that my colleague Philip has written, especially him since he is working on the part that installs the nodes initially. So he's the first point of contact when something doesn't work. And yeah, that's about it from what I wanted to tell you today. If there are any questions, I'll be more than happy to answer them. I'll take that as there are no questions. Thank you very much.